Another important section in ARA is the principal components. So principal components as analysis is concerned with explaining the variance covariance structure of a set of variables through a few linear combination of these variables. So the general objectives is data reduction and interpretation. So we are trying to reduce the number of variables and still explain much of the data. All right, so the steps in PCA is you need to first check if the data is suitable for principal component. Building correlation matrix to check for linear dependence. All right, so once that is passed, or then once you see that there is linear dependence and you have seen that your data is eligible for principal component, now you start developing the principal component analysis. Now you're building the model and model evaluation. The model that you have built, you need to evaluate it, checking the loading matrix, correlation matrix of the principal components. All right, so that's it with principal component. For us to get a bit together, the rest of the principal components for us to understand what it is really, we need to jump into ARA and let's just do some few analysis. All right, so in ARA I'm going to work with dataset that is within ARA. So the first thing that we need to do is to have our tools, our packages that we want to use in the process. So like I encourage or I advise for you to install a package in ARA, you need to work with the pacman, the package management. So the package management allows you to install other packages. It's a package that allows you to store other package. So I'm going to use pacman. So if you don't have pacman, you need to install pacman install dot packages. Then you put these codes and you type pacman. So pacman, once you run this command, control enter, and you run this command, pacman will be installed. But I will not do that today because I have pacman installed in my machine. All right, so I'm going to leave this command, but if you don't have it, please just run this command. All right, the next stage is now for us to install or load other packages. So I'm going to say pacman, then double colon, and I'll say p load. So that's the command for you to load other packages using pacman. So you start with pacman itself, and now you list the packages that you want to install or to load. So in our case, we need states. That's one package that we need for principal component that is going to help us develop a script load and develop other correlation matrix and to do the correlation tests. All right, so we also need is it dyplr. We need this package. All right, so these are the packages that we are going to work with during this session. All right, so now the next stage, now what we need to do is to identify the data that I want to use. I'm not going to run this command as well because I have this loaded in my machine. All right, so now the next thing that we need to do is to make sure that we have the data set that we want to use during the process. So I'm going to make use of iris data, maybe for you to familiarize with iris. I'm going to say first, I'm going to say library. I need the dataset package. Then I run this, and I'm going to need, let me view the iris. That's the one that I'm using, the iris dataset. All right, this is the dataset that is loaded within R. It comes within R, so that's why I've called for the datasets package, because I need a package that is within R. All right, so when I run this command, I'm going to get this dataset, and this is the dataset that I want to use for my principal component. But obviously, species, I won't need this during my analysis, so I'm going to create a new dataset. I'm going to call it DTA, and I'll say select. I want to remove that species. Select, so I'll just want to remove the whole column. I don't need it. So select, I am going to select from iris. I'm selecting, what am I selecting? The number of columns that I want. Oh no, the types of columns. I need column 1, column 2, column 3, column 4. So column 5 is the species, which is the one that I don't want. So I'm going to run this command, control enter. Right, if I want to view the DTA, my new data set, I'm going to say DTA and run this command. So this is the command that follows. So this is the data that I want to do my PCA. All right, but now what we have understood about principal component, we have agreed that we need to check whether the data is eligible for PCA. So how do we do it? We need to do correlation. So we are going to say correlate my DTA. Right, we need to see if this is possible. For us now to see it, we also need to get a mean of the correlation. So if the mean of the correlation of these variables is greater than 0.3 or greater than negative 0.3, that means that data set is eligible for principal component. So I'm going to say call DTA, then I run. All right, so this is 0.46, which is greater than 0.3, and that makes this data suitable for principal component. All right, so the next stage now that I have agreed that this is suitable for principal component is now to build the model. Let's build the principal component model, and we'll do further analysis on it. So to do it, I'm going to label principal component analysis. Then I want to say run this command printcom. That's the command that I'm using for my principal component, and printcom DTA. So now I'm using my new dataset, which does not include species. All right, so that's my printcom. The results are being loaded in PCA. All right, so now we need to evaluate the PCA, that the model that we have built. So how do we do it? The way we do it is we are going to ask for loadings. So I'm going to say PCA, and then I need some loadings. All right, then I run this. Okay, so when we are assessing this model, we want to make sure, or we just want to check whether the PC, the principal components, captures the essence of the original variable. That is what is important. Are we capturing the essence of the original variable? As you can see, we have four components, and we also have 4 variables. That means we are capturing the essence of the original variable. That makes it a good model or a good principal component. All right. So it shows also the weights. It shows that petal length is high correlation with component 1, and that means I can use component 1 to even explain petal length, because there's a high correlation, as well as component 2 is a high correlation with sepal length and sepal width. That means component 2 can explain much of sepal length and sepal width. All right, so that's how it is. That's how it is with these principal components. All right, the next thing is I also want to check whether the PCs are independent. So to check whether the PCs are independent, they should have a 0 or close to a 0 correlation. All right, so to do it, I'm going to say principal component, principal PCA, my PCA, and then I ask for scores. All right, I want to check this. Then I run this command. All right, I can view. Let me view this. Let me label this. Okay, let me label this PC. This is equal to this. Then I run this command, and I can view PC. View PC. I run this command. So I have four components. These are the 4 components, but I want to see if there is if there is independent between these components. All right, so to do it, I'm just going to say correlation, then PC, and we have agreed that for me to know that these components are independent, we need to have correlation which is close to 0 or even 0 itself. All right, so as you can see, we have this is the correlation, and if you can see here, we have a correlation of negative 2.8 times 10 to the power negative 16. That's a lot of zeros, and that is very close to 0, and this makes it the PCs, this makes us agree that the PCs are independent. Also, we can do some plots. We need to plot a script plot. Then I'm just writing plot, then PCA. All right, so let's run this and see what we have. Okay, so this is what we have. It shows, let me try to create, okay, let me create a new device so that we can see clearly. I'm going to say div, then new. This is a script plot, and then let me run this. Then I'm going to plot, but I want this to be a line graph, so the type should be equal to line. Then I run this command and I view. All right, okay, so this shows that component 1 has much importance than the rest of the components, and that means even if I work with component 1, I still get the significance of the model. So, but in principal component, we look at the elbow. That's where we decide the number of components to keep. So I would say if I keep component 2, is still okay, it's making sense. or even component 3. I can work with 3 components and still get much information from the data. All right, so that's it. And also I can get a summary of PCA to get the importance of these components. All right, importance of components. That means, as you can see from this, it means that component 1 explains 92% of this data. So component 1 has a lot of weight than the rest of the components. And the cumulative proportion, if I take component 2 and explains, if I take 2 components, the cumulative proportion, it explains 97% of the data. Then it's making sense. I don't need to, if I can explain 97% of the data, to me it makes more sense, and I don't even need to have the whole of the data. So that's data reduction and ease interpretation. That's the work of principal component. Even component 3, 99%, already it's making sense. I can work with 3 components and still get rid of what I want to analyze, or get an understanding of what this data is all about. All right, so that's it. That's principal component. All right.